And we're live. Hello everyone. Welcome to our first Amplify Creations development stream. We're starting a new monthly stream, or maybe bi-weekly, depending on how things go. And I'm here today with Paulo, which is one of our Amplify Shader Editor developers. And he's going to show us how to create a lit particle shader, right?
That's right, a smoke one.
A smoke lit particle shader, which is something we get asked a lot. So a better way to show it than with you guys watching the stream. And before we get going, I would just like to give you some more info. So this is going to be a stream where we're going to focus mostly on your shader creations and your support requests. So a sort of community spotlight, so to speak. And we're also going to feature some of the games that use our tools and things like that. And yeah. That's pretty much it.
Yeah, maybe if you have like a support case that you wanted to see how it's done, you can send it to us and maybe we can do a live stream with it.
Yeah, exactly. Feel free to send us your requests and we'll focus on that for the stream. So we're completely open to what you need. And we're also going to do a little short Q&A in the end of the stream. So if you have any questions, just let us know. But if it's something a bit more complex, we'd be happy to answer near the end of the stream, so just drop it in the chat and we'll look into it. And we actually decided to start on YouTube because a lot of you seem to follow us here, but if you're interested in going to Twitch, just follow us there. It's at Amplify Creations, and you know, we can make the transition to Twitch if you're interested. But for now, I think YouTube works great. And let's get to it. Let's see some shaders.
Yeah.
We're gonna swap to Paulo's desktop, and he's going to show you how to create the Lit Particle Smoke shader.
That's right.
So let's do that.
So, I have an empty scene here, and I'm going to show you how to build a lit particle shader. My main premise the main premise for this shader is how do you use the nodes to create a simple surface that can react to the light direction in a particle shader, which is a little bit different than a surface one. I'm going to show you just the final result first, and then I'll start with creating the shader itself. So this will be what we are going to create today. As you can see, this is like a really soft smoke effect. I didn't play with it too much with the particle system itself, just the shader. And all you see here is procedurally generated, so there's no textures.
No textures whatsoever.
Yeah, no textures. And you can see it reacts with the light direction, so there will be some hidden parts that it gets darkened and some that are lit by the sun. So yeah, this will be the final result. So let's start.
Seeing someone that's asking if we're also streaming video, and yes, we're streaming video. Can you see it now?
So I'm going to create a new shader. I'm assuming you have Amplify Shader Editor installed already.
Hope it's working.
And I'm going to create a new shader here, just a surface one for now. I'm going to call it Lit Particle Shader. This should open up a new window. And the first thing we are going to do is to actually select the correct template for this one. As you may be aware, the shaders that are used for particles are not the same as the surface ones. And in this case, we're going to use one of the legacy built-in ones. So you are not going to use the surface one, but one of these legacy ones. You can use GenLit, the particle alpha blended one actually, For this demo here, I'm going to start using the unlit just because it has more configurations to do, and I want you to show you how you do that. So in this case, I'm going to select unlit, and I'm going to now just do some basic configuration for the particle system. So I'm going to copy the final one for now.
Always good to have a backup.
And I'm going to create the material for this shader here. And I'm going to assign the material to the particle system. And this way we can start working with it.
And does this shader work on multiple platforms, or is it more of a PC thing, do you think?
Yeah, it should work on any platform. It will be just a really simple shader. It doesn't have any platform-specific code or anything like that.
That's always good. That's pretty good.
So I'm going to just, for now, just print like a simple color just to start. What I did here was create just a regular color node. I'm going to just select a random color just to see if everything is working fine. And then for the next step, I'm going to show you that the alpha blend is actually working, but we have to enable it. So in this case, I'm going to create an append node just to make sure that we are going to separate the alpha channel from the RGB one. So in this case, I'm going to use a different one. So let's say, for example, the alpha channel here and the rest there. And now if I change it, you actually don't see anything changing because we didn't set the shader to be alpha blended yet. So you have to go to the properties on the left side, and at some point you will see the blend mode group, and we are going to select the alpha blend one, which should change the configuration for the shader to work correctly as we want. So now it should, let's say, oh yeah, I forgot to change to the material editor.
Shame, Paul, shame.
Sorry.
I'm kidding. Yeah, as Diogo was saying, this is our first stream, so we're actually kind of struggling with the audio levels and, you know, all the good things involved in doing a stream. Like everything fails just before you hit stream. So we're still kind of figuring it out. But feel free to ask any questions as we go.
Okay, so now that we have alpha working, let's start with one of the initial tricks for the light system to work. The basic light that we can do using shaders is doing a dot product between the normals of the surface and the light direction. The light direction is actually really easy. You can just search for light direction. You should find the wall space light direction node. This works for example, if I just plug it on the RBG, you should see that the light or the color should change when I change the light direction. So for example, as you can see, it changes, so it's working correctly. But the difficult part will be the normals. And this is there's two tricks for this shader, and this will be the first one. So let's start with the dot product first. And by using the dot nodes and world normal node, this will give you the basics of a normal lit surface. We could use this, but in reality this will not work. We'll see just in a bit. Let's set this to 1. And what you're seeing here is that the light is actually reacting to the surface, but the issue is that particles are always facing the camera. So in this case, because the normals are always pointing to the camera, they don't actually look 3D or anything like that. Yeah. They do respond correctly to the sun. So in this case, when I'm looking from behind, it gets darker, and when I look directly in the direction of the sun, it gets whiter. So the issue here now is how we can simulate the correct response of like a volume of a fog, let's say. So we'll start with one of the initial tricks. It has a little bit of math involved, so bear with it. But it's really simple at the end. It's just like a regular math function to define a sphere. That's what we're going to do here. We'll start using the UVs, and we'll see just in a bit why. And basically what we want to create is to create something that resembles what the world normal node gives us, but not using a sphere, but generating one like it was a sphere. So in this case I'm going to change the coordinates to be centered, so sorry, something like this, and we are going to append this, not this one, and this should give you the basis of the x and y components. You'll see in a bit why. And we are going to define the circle or the sphere to the z component. In this case we are going to use the dot product again, and this is the part where that's a little bit heavier on the math side. So it's just 4 nodes, but you don't have to know all of this, but in this case it's a dot product, a 1 minus, and it should be the saturate, and this one square root. So let's see what this gives us. So if you do just the dot product, you actually get like a simple circle shape, and if we invert it using the 1 minus, you start seeing what we actually want to use as the z of our sphere. The rest is just the part of the math that actually gives us the correct spheroid that we want to use in this case. So right now we just simulated a simple sphere in a quad, and this will generate like something similar to this surface here, but there's still one piece missing, and let me show you the result for now. Let's delete this. So as you can see, now it reacts, but something is off. It's not actually reacting correctly. As you can see, the left upper side corner is always brighter and is not reacting to the position of the camera or the sun. This is because we are actually generating this normal facing the normal that the particle already has. So it's basically in view space. So it's always facing us. And our light node is actually in world space, so we actually need to convert one of these sides to the similar space or to the same space that the other side is. So you can think of it like this side here is in view space, but this side here is in world space. And this is the second trick of this shader, which is how you convert one of these sides to the correct space. And one of the simplest ways you can do to make this work is to create a matrix node that inverts or that picks this light here and transforms it to the view space, to the world space, I'm sorry. No, in this case to the view space, yeah, because it's already in world space. So we're going to use the transform direction node. And we want to transform it from world space to view space. Something
it's a very
like
heady node.
That's right. And this should, if I now hit save, this should now look a little bit more correct.
Nice.
So you are still seeing the borders of each plane, but if you look at the center, you'll see like a sphere on the center. So we can now use something to change the alpha channel. We are actually going to reuse some of these data here. So for example, this 1 minus would be enough. So if I plug it in the 1 minus to the alpha channel, it should give us a little bit more. Okay, it's still not working correctly. That's because you need to saturate it. And yeah. So now what we are still missing here is to saturate the results of our dot product, because what we're actually doing is that it's giving us a range of values between 1 and -1. So this is why we are getting this blue tinted side here. So if I saturate the content of this, something like this, for example, now it's working a lot better now. And let me just check my sheet here.
Starting to look pretty good.
Yeah, so right now we are actually seeing the borders of the.
How do you fix that?
Basically, what's happening is that the shader is writing to the depth buffer, and we don't want to. We just want to write each particle on top of another. So we have to go to our properties again and find the depth one and turn it off.
Just like that.
Yeah. So it's working a lot better now. And now it's basically how we change these blobs into something that is not just a blob. And for that part, we are going actually to use some procedural noise generators, and we have a bunch. We have Voronoi, we have the simplex noises and stuff like that.
Oh yeah, we recently made an update to our noise node, right?
That's right.
Awesome. So
we are going to just use the same one all over again, just because it's easy. You could use a texture here. It's just easier to use the procedural stuff, and we can actually control the procedural stuff using the particle system. But for now, we are just going to use the noise generated, the simple one. And what we are going to do is that we want to add something to these normals here that changes the normals ever so slightly, so that it looks like a soft cloud. And by what we're going to do is that we are going to use the generator for all of the axes of this normal map, or not saying that it's a normal map, but it's for this normal here. And by what we need to do is to duplicate this a little 2 times at least, one for each axis. We're going to feed it the UVs, which are it's our base for our particle system. And we can even change the size here for something that it looks a bit different, for example 1.5 and 1.4 and 1.3, just to make them look a little bit different. And because the noise being generated is always the same, we need to offset it a little bit, so we are going to add a random value, just a random value, doesn't mean anything, at least not for now. So we are going to add just a random value to each one of those. And as you can see, just by
just offsetting a little bit.
just offsetting a little bit, just so they look different. And finally, we are going to append it into a new vector. So it's like a random noise vector, I guess. And we are going to scale it using a property, let's say like a normal scale, I guess. Could be like, I don't know, maybe from 0 to 2. And finally, we are going to add this to our normal map. Something like this. Okay. So now if I change the normal scale, you can see that it's changing the way the cloud is being formed. However, you can see that it still looks like a sphere, just a sphere that has been, I don't know, transformed or changed.
Yeah, the outline is still
Yeah,
kind of
the outline
spherical.
is still a sphere. So we need to change that as well. And we can actually just reuse one of these noise nodes to eat the outline just a little bit, so it looks like a real cloud. So let's say that we are, instead of using this directly, let's create a register node just to make our lives a little bit easy. Let's call it alpha for now. And
Just for the people watching, can you explain what those nodes do?
so yeah, what this does is whatever you connect it to the input of this node, let's say right now I'm going to connect the saturate node, it's going to be relayed to the other node. Even if I duplicate this a couple of times, the content of this node is the content of this one. So it's just a way to clean up the room and not having wires all over the place.
Yeah, really, really useful.
Yeah. So for now we have the same old alpha, and we actually want to just multiply this one for one of these ones. So let's say the Z1, and this should already look a lot better.
Yay!
It still looks a little bit on the sphere side, and we can actually improve this by just using maybe like a smooth step node or something like that. For example, something like this. This should look a little bit more smooth, I guess.
Nice one.
So this is the basis of our lit shader. Now everything I do is just related to how it looks. For example, right now we are seeing like a cloud of black and white. We actually want to do something like a cloud of, I don't know, maybe brown or
some kind of dust.
Yeah, something like a dust color. And what we need to do is to just use the result of our dot product and pass it to some color nodes just to tint them as we want. And a good way to do it is actually using the particle system. So if you use the vertex color, that vertex color can be configured in the particle system, and we can use that inside our shader. So in this case, I'm going to use a lerp node, and I'm going to connect the result of the dot product to the alpha node. Let me just reconnect these. And I'm going to select two colors that should make sense between the dark and light part of the smoke. But I'm going to use like a tint color that comes from the particle system itself. If I select the particle system, I actually already set it up. So in this case, I set it up in like this. So it starts white and then ends like a brownish color. And I'm going to use the vertex color here. So this is what returns whatever we put here. So if I, for example, select green here, and I put it on the light side. Let's see. What I did wrong was I didn't save this.
It's got some kind of tint.
So what I'm doing wrong is it's not picking up. Yeah, my bad. So it's still too dark. So it is changing, but not how I want it.
This worked in rehearsal.
Yeah.
No, it's all right. We'll figure it out. I mean, we got the developers in the room. Yeah.
Okay.
Oops. Sorry.
So let's just move on for now. I'll figure this in a bit. I'm going to change the alpha of each particle by using the vertex color again. So in this case, I'm going to reuse the vertex color node. I'm going to duplicate it, and I'm going to multiply its alpha result to the other alphas that we already calculated. And by doing this, I actually set it up in the way that when the particle system starts and ends, it starts at 0 and ends at 0 again. So it gets it's like just a simple fade in and fade out effect, I guess. So now you can see it starts. If I restart the smoke, it fades out here, so it's working. However, if you can see the particles on the ground, they don't look really good. So what's happening here is that the particles are just intersecting with the plane of the floor. So in this case, we want to use something to simulate that they are actually fading from the floor. And you should probably know this as soft particles, this effect. We are going to use just a node to create that. I'm going to use the depth fade node for that. And again, we are going to connect it to the alpha channel by multiplying with everything else. So if I save it now. Now, this happens because the depth fade node actually gives us a result that it goes above 1 and below 0.
But it's a nice effect.
Yeah, it's a nice effect, but not the one we are looking for. It's an actual simple fix.
Yeah, but it looks like some kind of kaleidoscope.
Yeah.
Wacky thing. Some people might enjoy it.
The simple fix is to just hit the saturate button here, it's the same as using a saturate node here, which will clamp it from 0 to 1. So in this case, I'm going to just use the tick here, and it should be fine.
Nice.
And you can see the particles now, they start fading in from the floor. Okay. For this part, it was going not really good, but we are going to fix it in another way. We are actually going to use some of the light nodes, especially one that it should be here all along, which is the light color node. We want to paint the smoke with the light color and not just any random color. So we are going to use two colors for this, the light color one, and we are going to use the light attenuation. And this is only here because at some point we want to make this shader work for point lights as well, and point lights need to use the light attenuation node in order to be able to do the smooth effect from the full brightness of the point light when it's close to the light and then fades away at distance, at farther distances. So in this case we are going to multiply these two, the color with the light attenuation, and we are going to lerp the results. And one of the things we are going to have a problem with is going to have it's this dark part here, so we are going to just select a random color for now, just so it doesn't stay like black all the time. Okay, so in this case, let's see. So now it's this gray here, and it should now be tinted as the light color. If I change my light here, let's say to a red, I guess, and it's still not picking up my color.
Oh, is it because the lerp is as a float? Or? something about this community.
Oh yeah. So yeah.
I can't take credit for that. It was one of the developers
Oh yeah.
who messaged me.
Sorry, my bad. So it was a simple fix. It was using the append node here. That was the problem. So yeah, if I now change it to the initial color, something like yellow or something, it should look a little bit better. And finally, we can then tint it as we see fit with the vertex color, which we can just multiply the result, for example. Something like this. And now, as you can see, the top ones are a little bit darker, more brown, I guess. That's because the
It's from the color you were setting in the
Yeah.
particle, right?
yeah. So I can finally change it to green, I guess.
Yay. Toxic smoke, yes. No,
That's
make
right.
it purple. No, I'm kidding.
No, I want it. Why not? So this is the basis part. We can actually improve this a little bit. We could, I don't know, maybe create like a shader function from some of these techniques here, for example, this one. But for now, we are just going to add just a little bit more detail on this by making it work with point lights. So for now, let me just change it back to white. I have a point light here which is red. And when I turn it on, let's see what it gives us. It gives us nothing. So what's happening here is that our shader is actually only being set up to work with the forward base shader pass, which means it will only pick up the first light in our scene, and the directional light we have here is always the first light we have on our scene. So it's only picking up the direction from the directional light, which is our sun, and not the other ones. So what we want to do is actually want to add the forward add pass, which will run for each and any other point lights that we have in our scene. So to do that, we actually need to change our shader type, or in other words, we actually need to change our template to one that has both of these shader passes, which is not the case of the unlit one. The unlit only has one. So we're going to use this multi-pass unlit, which actually has a bunch of the other passes. It has the one we were using before, the forward base, and it also has the forward add that we need for now, and it has the passes for the shadowcaster and deferred mode. For now, we are not going to use the deferred one, so we're just going to deselect it, and we are also not worrying about the shadow casting part, not for now, and not for this session, I guess. So we are actually going to deselect it as well. So now that we have both of those passes, we can actually even select those and change the properties of each one. For now, we are going to do or redo the things that we were already doing on the other one, which is to set it up to be not writing to the depth buffer, doing the alpha blend stuff, and we're also going to change the text here just so it becomes a transparent type shader. So in this case, we're going to change the render type to transparent, and we are going to add a new one, which is the render Q, which you get by typing Q, and it should pop up the Q field here, and we're going to change it to transparent as well. So now we can connect our alpha here and our color node here, and we no longer need the appended one. Okay, let's see what we get. Let's for now take the point light away, just so we can debug this. Again, we are having the problem with the depth buffer, and that comes from, let me check. Okay, so the blend mode is okay. Transparent. What's wrong?
I'm being told that the camera is overlaying the shader properties. That's not good.
The camera?
Yeah, can you hide our camera? Maybe, since it's easier for you to hide our camera there.
What do you mean?
Our webcam.
It's hide. It's
Can you hide it? Because it's over the properties of the shader.
not following. You want to-
Sorry guys. I'm just gonna hide this. Yeah, now they can see the shader properties.
Sorry.
The node properties, sorry. Sorry
My
folks, we
bad.
kind of missed that because I'm previewing the stream on a very small screen, so sorry about that.
Okay, so what's wrong here? It should be not the color. Let's debug this by connecting just the dot product result, and it should be something on the alpha part. So let's see. This is correct. Everything looks fine here. Maybe this one. This is also okay. I'm checking the other one that I already have built, so just make sure everything is it's fine. This is the problem. Yeah, found it. So I set it up wrong. So I set it up as default, and by default it's on. So I have to change it to off. Yeah, my mistake. Let us continue then. Okay, now it's working. So now if I turn the point light again, let's see what we get. Now we get something really weird, which is whenever the point light starts touching the rest of the particle system, we get some really weird results. What we have to do here is that we have to filter some of these calculations for the forward add pass, which means we'll have to filter it according to the pass. And the best way to do it is actually to use a static node, or in other words, the best way to do it is using the shaded keywords that define the path, and then we use the static switch to fetch those keywords and do something different on some parts of this shader. And we do this by using then the static switch, and we want to change the create to fetch the mode, and we should have like a set of predefined keywords. You could type your own here. So in this case, I'm looking for the forward add one, and I do not want the material table. So I'm just fetching an already existing keyword, and I want to filter some of these results so they don't actually do some of the stuff we are actually doing. So we want to filter the color, and for now I'm going to select like this, and I'm going to change the results. Let's see, since we only want to paint our cloud as red, we only want the light attenuation multiplied, or the light color multiplied by the result here. This should already do something. It's almost working, but as you can see, some of these alphas are not right. You can see the edges of the quad that defines the particle, and this is because we actually need to change the alpha a little bit as well. So what we need here is to change, or actually I think we only need to multiply by the alpha value, if I'm not mistaken. That's right. Yeah. So finally we have like a particle system that reacts to the sunlight and to any point light that we throw at it. So if I duplicate it and change the color, for example, as you can see. However, if you now look behind the point light, it doesn't actually picks up anything. We can, and you could change the result of the dot product to be something more smooth. For example, we could use like a scale and offset node to change the results, because right now it's going from 1 to -1, right? That's why we have the saturate node. But if we change this a little bit, so instead of going 1 to -1, it goes from 1 to 0. Instead of just clamping it like we are going to do, we get like a softer result. So let's say if we multiply by 0.5 and add another 0.5, you can see that we now go from 0 to 1 instead of -1 to 1. This should provide a little bit more soft results, and the color of the point lights bleed through a little bit more. And you could, for example, create a new property here and change these values around at runtime. But for now, we are just going to leave it as there. So the only thing here that is missing now, if I play this particle system, I don't know if you can pick it up, but all of these particles are using the same noise texture. So they are actually all the same, even though they are really mixing up well. They are all the same image. It's like I'm using a texture, so I didn't actually gain anything from using the noise generators. And one of the things we can do to actually make them all different from one another is to feed some information from the particle system to the shader, and then change these offsets here with that information. And we are going to do this by using something that the particle system has, and I already set it up, which is the custom vertex streams. So I beforehand added this stable random value, but I'm going to delete it and just add it again. So here you can actually add random stuff, and literally random. So I'm going to use a random value, and what this will do is that it's going to add some value to the vertex coordinate at the z component. So the first one at the z component. So this means that if I now use the vertex text coordinate node, and if I select the first one, which is actually it's already selected, it's the first one. If I pick up the z component here, which is the w here, I now have the access to that random value, and that random value will be different for each new particle. So this means that if I now add this value to each one of these, they should give a random particle for each new particle.
Awesome.
So yeah, that's how we create a simple, I guess simple lit shader.
Somewhat simple, yeah.
Yeah, it's a little bit on the advanced side, especially this math part here, which is the only thing that you probably had to look online for, but yeah.
Maybe this is something we can offer in the actual package if
yeah, for sure.
If users are interested. Yeah.
Yeah, I can even spice it a little bit more and create
It's
like
more
a
pizzazz.
yeah, and yeah.
Yeah, that's pretty good. Yeah, everyone, I hope you enjoyed this sort of short tutorial on how to do lit smoke particle shaders.
Do send us feedback, and do ask us questions, and maybe we can create the shader that you want for the next stream.
Yeah, so if you want to, like we said in the beginning, if you want to see us cover anything specific, just let us know on Discord. By the way, the links are on the description of this video. So just let us know what topics you want to see covered, or if you have any specific support questions. Paulo or one of our other developers would be happy to discuss it in this stream, and it's probably best than just typing away on Discord. It's something we can discuss real time with you, and we can all interact.
Yeah. And one of the good things about using this format is that on Discord, a lot of the things that we do and we actually answer, gets lost in
Yeah,
time.
ends up getting one.
So by using this format, we can give us answers that we can actually show on the computer running, and everyone can see at some point.
Yeah, so the VOD of this video will become available on our channel, so we're going to keep all the streams, and you can just, like Paulo said, go back and watch them at any time.
Yeah.
And that's pretty much it for our first stream. We kept it simple for you, but you know, let's take it wherever you want it to go. That's pretty much. And just one small note before we go, before I forget, I have to say this: if you're still on the fence for Amplify Shader Editor, it's currently at 50%
That's right.
off during the Black Friday sale, and also Amplify Imposters, of course, our one-click optimization package that Paulo here had a good hand in.
We can also check other products, so we can do a stream just using imports or something like that.
Oh yeah, absolutely. In the future, if you want to see something else, like for example our latest Amplify Painter or something like that, we'll try to cover different things. So it's not always Amplify Shader Editor, but it's probably going to be mostly focused on editors, because you know, Amplify Shader Editor is one of our main tools, if not the main. So. But yeah, one small note before we go. So this year we decided to take some time off during Christmas. So we're going to be away starting on the 16th, and we'll return on the 2nd of January. So it's the first time we're going to be completely offline. So our apologies, but there's not going to be support this year. But we'll be back.
I'll probably still lurk around.
You can't. It's mandatory time off. Yeah. So yeah, until next time, we hope you enjoyed this first stream, and we'll see you maybe in a week or so.
Yeah,
a week or two,
soon.
we'll see. We'll announce it.
Soon TV.
So yeah, goodbye everyone.
See ya.
And we gotta press ending over there. No.
This one.
Yes.